Gracie Ermi, and I am a research software engineer at Vulcan Inc. in Seattle, Washington. And today I'm here to tell you about how we at Vulcan are using artificial intelligence to aid wildlife conservation, and specifically how we're using AI and machine learning and applying that to wildlife surveys, which are an important tool in conservation. So I'm going to start off by telling you what is a wildlife survey, and then I'll dive into how we are applying machine learning to some of the challenges of a wildlife survey. And then I'll go into an example where we applied machine learning to an African elephant survey, and so you can see how that looks and what that kind of looks like. So first, what is Vulcan? Vulcan is a Seattle-based organization founded by Jody Allen and the late Paul Allen, and Vulcan's mission is to make and leave the world a better place. And we do that by tackling some of the biggest problems in oceans, climate, conservation, and communities. And a lot of our work has to do with building technology to support those 4 areas. So today you'll hear about technology that we build to support conservation specifically. So what is a wildlife survey? A wildlife survey is a really important tool that wildlife scientists can use to gather information about the animals that they study without disturbing them at all. And this looks like collecting a lot of images of those animals in their habitats without disturbing them or bothering them. So there are many ways that you can conduct a wildlife survey, but no matter which way you use, what you're trying to do is gather information such as animal population counts, the health of the animals, where the animals are living, and more. And this data that can be collected from these images can be used to inform policies and laws to help protect animals going forward, as well as to mitigate really a lot of the negative human behavior that goes on that affects the animals and in a negative way. So some of the ways that wildlife surveys can be conducted are via a plane. And so that's what the example that I'm showing you today, that's the method they use. And in this method, cameras are attached to the outside of the plane, and as it flies over the area where the animals live, the cameras are taking pictures, and there are also humans in the back of the plane that are counting the animals as the plane flies along. You can also use underwater cameras, like we did in a project called the Global Fin Print Project. And in this project, we were trying to survey sharks and rays, and so we needed cameras down underwater to view the sharks and rays as they were swimming around in their habitat. You can also use camera traps, which are cameras that are hidden at ground level, and they have a motion detection feature. And so when animals walk past, it will snap pictures of the animals, and you can survey the animals that way. And then also drones, taking images via a drone can also be a way to conduct a survey. Some of the challenges that come with a wildlife survey, though, are challenges that we really thought machine learning could apply to. So a lot of the challenges that we did apply machine learning to happen after all the images have been collected. So you collect, potentially hundreds of thousands, if not more, images during a survey. And to get that information about animal population counts and where the animals are living, you have to have people go through, look at every single image to either find the animals in the image or do some sort of measurement on the image, on every image, to get the actual data that is important and that will inform these laws and policies going forward. And we really thought this is a time-consuming process. Wildlife researchers shouldn't have to be spending so much of their time on this process, and it can be expensive to do all of this image processing at the end, and it's also a really tedious task, especially in the case where there are not very many actual animals in a lot of the images. A lot of the process involves just throwing out empty images, and so we really thought machine learning could come in here and help solve some of these challenges so that wildlife researchers can spend their time more effectively doing the parts of their job that we really do need human experts to be focused on, instead of things like this image processing task where we hope that we could offload a lot of that work onto a computer instead. So here is an example of an image taken during an African elephant survey. And this is, I hope, is going to illustrate to you how challenging it is to do the task of the post-processing of the images from the survey. So there are 9 elephants in this image, and I'll let you look for them while I continue talking about it. They're very hard to see. This image was taken from a plane, and so the elephants are very tiny from this perspective. They blend into the background super well. And you know, it's sort of a fun task to look at one of these images, right? It's kind of like a game to find the elephants in one of these images. But imagine having to look through thousands of these images and how tired your eyes and your brain would become from this pretty boring task. And on top of that, we, in this survey, took around 500,000 images, but only 0.5% of those images have elephants in them. So if you are given thousands of images to look through, only a couple of the images in your batch that you as the human annotator are given might have elephants in them. And so it's just an especially boring task. And we figured we could use human brain power for better use if we could teach computers to do this task for us, to find the elephants in the images for us. So here is the result. Here's what our machine learning model that we trained to find the elephants, here's what that model found. So it successfully did find many of these elephants. And what you can also see in the image, on top of how successfully it found some of the elephants, it also did miss a few of the elephants in the image up behind that clump of trees or bushes up there in the top left corner. And so what this also illustrates for us is that the machine learning is never going to be perfect. And so we really view it as an assistive technology in this case, where if we can just get the machine learning accurate enough to be able to help us throw out and eliminate a lot of those empty images, the vast majority of the empty images, then we're left with a much smaller set of images that the machine learning model thinks there is an object of interest, an elephant, in the image. And we can just have the human experts go through and look at that much smaller set and correct what the machine learning model did find. Any false positives, get rid of those, and then also put boxes around the elephants that the machine learning missed. And we can just really leverage the strengths of humans and computers together to make a better solution than they would be apart. So this final example will show you just a few more pictures from the African elephant survey. And this is the machine learning model running in real time, finding elephants in these images. And so any little green boxes you see in the images is where an elephant was found by the machine learning model. And because it's running in real time, you can see it only takes about 3 seconds per image for the machine learning model to compute and find the elephants in the image. Whereas we found in our experience, human annotators take anywhere from 2 to 5 minutes to find the elephants or determine there are no elephants in an image. And so the potential for really a lot of time savings by using the machine learning model is just very great. And we are excited about this technology and the time that it can possibly save for wildlife researchers and allow them to do even more great work than they already do. So thank you for listening. Some key takeaways from my talk are wildlife surveys are a very important tool in conservation. They get us a lot of really valuable data about the animals that we all care about protecting so much. And machine learning can really assist us here. It can help save time and money and save humans from having to do some really tedious, boring work. And then finally, you can get involved in this work. The conservation technology space is very open with a lot of potential for new discoveries and innovations. And if you have technology skills, you can be a really valuable asset to the conservation field. So I would just highly encourage you to consider using your skills to contribute in a really impactful way in the conservation space. So thank you so much. Feel free to reach out if you have any questions. And thank you for listening to my talk.